Let's talk about orthogonal matrix. So let us consider we have a matrix A whose order is n cross n. So I will call this matrix to be orthogonal if A inverse will become equal to A transpose. So either you can apply this condition or A into A transpose equals to A transpose A equals to I. If this product gives you identity matrix or this product gives you an identity matrix, of course these two products will be same, then you can say that this matrix is a orthogonal matrix. And you should note that this is valid only for a square matrix. For a rectangular matrix you cannot see. Okay, so for a square matrix you can say a matrix to be orthogonal if this condition is satisfied. Why is it only valid for square matrix? Because only for square matrix you can find the inverse. For rectangular matrix or non-square matrix you cannot find the inverse. So of course this relation will be invalid in that case because you won't be getting that, right? So this will be orthogonal if this condition is satisfied. So whether you check this condition or this condition, whichever you are comfortable, you do that. Another definition for this orthogonal matrix, we can say that, let's say we have a matrix A and these have been written in the terms of row vectors or vector spaces. Now this is a 3 cross 3 matrix. You might be wondering, sir, here I have got only one row and one row and 3 columns. How can we write this as 3 cross 3? Dear, these are not vector elements, these are vector, you can say that these are not elements, these are vectors. Okay, this x1, x2 and x3 are not matrix elements, rather these are vectors. Okay, so x1, x2, this is a short form of writing any vector. Okay, so I have written this vector A in terms of another vectors. Fine. Now I will call this vector to be orthogonal if the inner products is 0. How can we find the inner products? Inner products we will learn, but before that this statement is true but the converse is not true. If the inner product of the vectors is 0, you cannot say those matrix to be orthogonal 100%. Okay, so this is a straightforward statement. That is one way it's correct, that if a matrix A is orthogonal then the inner products of these vectors will be 0 but the converse is not true. Now what is this inner product? So let us, here as you can see, this x1 is actually this. Okay, so this is an R3 means it's in 3 dimensions, so that is why we have got only 3 different coordinates x, y and z. Had it been in 6 dimensions, we could have written something 6 elements like that. Okay, so anyways we will talk about all these later, but for the time being you just understand what is this inner product is. We have matrix 1 which is x1, whose elements are x1, y1, z1. We have another matrix x2 whose elements are x2, y2, z2. Now if you want to find the inner product, what you need to do is, this is the formula that you have to apply. It with the symbol is x1, in small parenthesis or small bracket you can write x1 comma x2, and it means that you need to first take the transpose of one matrix and you need to multiply with another matrix. Okay, so this you have taken the transpose of this, so this column vector gets converted into a row vector. Now this second vector remains as it is and simply you need to multiply, or directly you can do that. You need not to do all this in shortcut, or indirectly what you need to do is you need to take this element and then multiply with the corresponding elements and add all these elements. So here x1 x2 inner product, if you are interested, then simply do x1 into x2 plus y1 into y2 plus z1 into z2. So this is quite more easy. So let's see an example out here. We have a matrix M and these values are given as 3 by 5, 4 by 5, 3 by 5x, and this condition is given. So if this condition is given, what they are trying to say? So indirectly they are trying to say that M is an orthogonal matrix. So if M is an orthogonal matrix, then only this condition is satisfied. So if this condition is satisfied, so that means we can say that the inner product is 0, right? So if M is orthogonal, since this is the condition which is given, so and hence we can say that the inner product has to be 0. What is the inner product? I told you, you need to multiply the corresponding elements. So 3 by 5 multiplied with 4 by 5 plus 3 by 5 multiplied with x, and this term has to be 0. So from here you will get the value of x as minus 4 by 5. Very short and simple question, but quite interesting. Now let's see some properties of orthogonal matrix. Now let us consider we have two matrices, that is if A and B are orthogonal matrix, then AB, BA, A transpose and B inverse are orthogonal. Do we need to remember this? No. If you are interested to find or to check whether a matrix is orthogonal or not, simply apply the condition, that is A inverse is A transpose. If that is coming, then of course this is orthogonal, otherwise it is not. Now we have another matrix called normal matrix. So which is a normal matrix? A normal matrix is one which you can say that A into A transpose is equal to A transpose into A. If this condition is satisfied for the real matrix or real values, then we can say that this matrix A is a normal matrix. And for complex value, if this condition is satisfied, that is A to the power of theta into A is equal to A into A to the power of theta, then also we can say that it is a normal matrix, because you know then in matrix multiplication the order matters a lot. So every time you cannot say that A into A transpose will always equal to A transpose into A. No. If this condition is satisfied, then only we can say that yes, it is a normal matrix for real numbers and for complex numbers. Fine. So these were some important things related to your orthogonal matrix. Now moreover, sometimes it happens that they will give some functions and they will ask find the inner product. So one extra information I am giving you. So one extra information is that if there are two functions f and g, and if they are asking to calculate the inner product if any interval ab, then in that case you can simply find the integration of this part, right? So you need to find simply the integration of this particular thing, that if you want to find the inner product of two functions in AB, then integrate in that interval AB f of x, multiply these two functions and integrate it with respect to x. You'll get the inner product of these two functions. Okay, so that's a different thing. So that might be asked in calculus, but inner product in matrix you need to solve like this. See you in the next lecture. Till then, bye.